You might mention my last book. It just came out. It's called Big Megalo Beach, in station Vienna, because in this book I describe my 40 years of experience in testing, not only testing, but also re-engineering, maintaining, and so forth, here in Middle Europe. So I say Middle Europe because I'm constantly traveling back and forth between Germany, and Austria, and Hungary. And I actually came to Hungary the first time 40 years ago. And, well, actually 39, because it was 1978. And we founded a test factory here in Budapest. So this was the first commercial test laboratory in the world. Yeah? And it was here in the SAMOK and the SKI institutes. And there, the Hungarian colleagues tested programs from Siemens for the German railroad. And the interesting part about this first project was that the payment was made on the basis of errors reported and cases tested. So if I remember right, we got something like 75 German marks per test case and 150 marks per error, reported error. And the managers here at that time, the Elftarshock and the institutes, were very hesitant about this project because they didn't know what this was all about and they couldn't imagine it. And I took a lot of convincing. So this is very interesting part of my book was this first trip to Budapest and meeting with the Elftarshock here and trying to win them for this project where they didn't even know what they were doing and how they would get the money and who would do it. And this. But in the end, they agreed because they needed the money so badly. And we tested this software from Siemens. And in the end, everyone was fairly satisfied. I mean, we tested several thousand test cases, several hundred modules, and we reported 500 or more errors during this time. So this was actually the beginning of testing in Hungary. Now, so I always come to the HUSTEF conferences ever since the beginning. It was 2007 or so, and try to say something original, but it's getting harder and harder because I don't have the access to the projects that I once used to have. So the projects I'm working on now, two projects. One is here, we're doing it actually in Budapest, but it's for Volkswagen in Germany. It's reverse engineering legacy systems, which includes setting up a test environment. And the other project is in Vienna for the National Archives, migrating the data. And the data has to be tested. And in both of these projects, the business rules play, yeah, it's sort of play an important role. Yeah? Okay, so you may be asking, what in the hell is a business rule? What is this old man here talking about, business rules? Well, business rule is a term which has been around a long time. It goes back to the 70s, you know, and the business analysts were defining information systems, and these systems were governed by rules. So it's a law or custom that guides the behavior of system actors in an IT system. So from the viewpoint of business, a business rule is a regulation to ensure a desired behavior, how the system should behave. And in the IT, a business rule is really a requirement. For instance, a notice is sent to an account owner if his account is overdrawn for more than 30 days. So this is something like a law in the company that has to be built into the software. Manifesto. Yeah. The term business rule was first used in the business system planning approach used by IBM. They had a methodology which they called business systems planning. Today you would talk about business process modeling, but the forerunner of business process modeling was business system planning. And the rules were general statements of company policy, such as billing is done on a monthly basis, or we don't hire anyone under 17. So these are rules that have to be put into the software. In 1989, a business rule group was formed by the ACM, and they wrote a white paper with the title Defending Business Rules. There was a second paper which was written in 2000, and in 2002 there appeared a business rule manifest, sort of about the same time, a little later than the Agile manifest, but this was the business rule manifest. So in the German-speaking world at the universities, especially the Gaststätte Informatik, the Wirtschaftsinformatik, a lot of master's students deal with this subject. They write papers on business rules. So business rules are declared in a natural language statement, declaratively, so they're not procedural. And the sequence of the statements is arbitrary, so it doesn't matter in what order the rules are checked, they just are defined. They have to be checked. And they are defined independently of the responsibility for who, where, when, and how they are enforced. The rule exceptions are expressed by other rules, and they should be expressed in such a way that they can be actually automatically validated. It should be some kind of parsable statement that can be interpreted at test time. So verified automatically, and they are the formal logics. The first order predicate logic shouldn't be too complicated because the business people have to write them. And here I've given you some samples. You can see here that you have to be at least 17 to be employed by us, or the final price is the total price plus the added value. And you compute the added value. The account status is frozen if the balance is less than 0 minus the credit limit. Payment date less than the billing date. And give ticket if the park place is taken by a student, because students have no right to use the parking places, only for the professors. Our lectures are canceled if less than 2 students register for it. So the rules exist long before the requirement specifications. When you set up a company or an enterprise, or you want to build a factory, then you define the rules for running that factory as a whole. And later, when you start to develop applications, then you write requirement specifications for those applications in which you build in the rules. Yeah? You implement the rules. So here we see formalized business rules referring to a customer order, reject the order if customer not known, or customer credit less than customer limit, except if customer known, messages reject customer if the return code is 1, and so forth. So these are actually assertions about the states of data which you make. And notice here that the order is not important. You're making a declarative statement about the state of the data at this time, at this moment in time. You take a snapshot of the internal storage. You have all the data values there, and now you're checking them against each other. And this is what you want to ensure the integrity of the system. So we actually go from business rules to test cases at one point or another. We arrive at the test cases. First, the rules are converted from English to some predicate logic. Then it go into the requirements, and parallel to the requirements, they go into the test scripts, the assertions. And then we have a system design, and we have a test design. So this should always be parallel. Parallel to development is the test. So I wanted to show you here, if you get these slides at home or something, you can study this. But these are real rules taken from the National Archives data migration. This is about clients and their birth date and their last name, first name, mobile number, and so forth. Well, since we're migrating the data from a previous database in Microsoft SQL Access into a more modern relational database, Postgres, then we already have the old data. And we can compare the new data with the old data at the attribute level, but you will notice that some data is changed. For instance, for some silly reason I can't explain, they used to have the house number and the street were separate. Now they put them together in one column, one field. You have the house number, hyphen, the street, and then the hyphen and the house number, you see. And this happens a lot, that they are putting the data together in another way, and then they have different variations of the data depending on the values of other data. So you must compare the data with one another. I've been spending the last months struggling with this data here and trying to balance it out. You see here is a sample of an assertion script. So in front of me, I have the rules, the migration rules, conversion, how the data should be converted and transformed, manipulated. And then on my editor, I sit down and I write this like the new title is the old title, or it's the old degree. The new degree is either doctor, master, bachelor, diploma, but they've changed everything from German over to English. And here you see the old street with the underscore and then the old house number. Yeah? So I'm defining what the values should be. And I have a tool called data test. It reads this code and creates something like a bytecode. A bytecode which is then executed in the test. It reads in the data from the old database, and then it runs these comparisons on it. Yeah. And if it isn't true, the assertion is violated, then it reports an error. And there are 7 million archive documents, UCMAN, in this database system. Yeah. So here we see the reverse engineering of business rules. So I'm in this one project in Vienna, I'm forward engineering the rules, starting with the requirements specification, or actually the definitions of the data, the new data. In the other project, which we make for Volkswagen, we start with the source code and try to extract the rules from the source code together with the test cases. So you see an extracted business rule. For every output variable, you have to first identify which variables are outputs. Yeah? And it should also identify whether they are relevant or not to this application. And then you look for the procedure where this data is set or calculated, who performs this procedure. These are programs written in COBOL. And if the conditions are met. If the conditions are met, then the value is set for this data from the arguments which flow into this algorithm here. So this collection, extracting business rules from source code, is a real research challenge. Yeah? And well, I've given you a sample here where you can see the data at the top, it's being set. Yeah? This is a character field occurs 7 times, and it's being set in different COBOL procedures under different conditions. Yeah. And here, when you run the test, you can see on the left the names of the data. Yeah. Here, such as the supply number, the article price, and on the right you have, I use the terms new and old. The old was the original data value, or if it's the data value that you expect. So old is also should be, in German, the soll. This is what it should be. Article price 1050, and if it's not, you get an error report. Well, this is a big help in testing big data, like these National Archive data with 7 million records, and each record has 20, 30 attributes. You could never control this manually, looking at every individual table and the lines of the table. This recognizes lines that don't match, that don't fulfill the requirement, and then it sorts them out in this report, and then you're able to find the errors much quicker. So I wanted to refer to this project in the US to show you that business rules are used there. The University of Memphis participated in a project together with the Federal Express, and they defined 2,000 business rules. Yeah? To check the shipping transactions. And this way, the requirement engineers and the testers working next to each other, they had a common point of reference. The rules were formulated in clear, unambiguous, well-structured English. Yeah? And they used these rules for the test cases. They converted them automatically or partially automatically into the test cases, and then they could test the system, and this helped them to improve the defect detection ratio from 54 to 88%. Thus, the use of business rules really provided a good, clear advantage to the testers in this particular project. I mean, this is a typical business application. So in closing out, I can say that business rules apply to all applications in a particular enterprise. So you need someone in the company who's responsible for the rules. And now today you also have rule engines. They're tables wrapped in a module, encapsulated in an object, and whenever you come to a particular decision you have to make, you send a request to the rule engine, and the rule engine answers whether the rule is true or false. Is it met or not met? And so you don't have to build the rules into all of your code programs. You just use the central rule modules. So the rules are an important source of test cases. They should be formalized and converted into functional test cases. The goal, of course, is you want to hit every rule. You saw in this project in Memphis in the US for Federal Express, they had 2,000 rules, so you want to hit every rule at least one time. And you measure the coverage of the rules, that it's identified and instrumented, and the result of the rule is validated against an output assertion, what the result should be. So by concentrating on the rules, everyone is always talking about that test has to be faster. You can't test everything, so you have to test what is essential. Concentrate on the essential, and the rules really, that what is essential, you test the rules first, and if you have more time left, then you can test what's around the rules. So by focusing on the essential rules, you can shorten your test and still make it better. Okay, that was my talk in time. Yeah. You're going to ask some questions.
Thank you very much. We have time for some questions, but we do not have in Slido. So do you have any questions now? Please.
I thought the questions would appear here on the...
Yes, but unfortunately we do not have in Slido.
Okay, well you have to interpret for
again,
me because Siget Wajo.
Yeah. How do you handle the latent rules?
How do I handle latent rules, meaning they're in the background waiting to be triggered? Is this true? I have no particular algorithm for doing this. They would be built into the rule engine. I'm saying how it could be done. And when this particular state comes up, then these rules are triggered, although they're latent. But it's not a very good answer, but